want to talk today about the inspection of some tough products. Here's an example of some 40-pound blocks of cheese, fresh cheese, and the nature of the toughness with regard to inspection with metal detectors. This is a very difficult product for metal detection in the way that metal detectors work, because the only way that any metal detector can detect metal is either by having the product or having the metal be conductive or magnetic. And in this case, cheese also has a high degree of conductivity because of the moisture and the salt content and fat and so on and so forth. So cheese, in particular, large blocks of cheese, large amounts, large masses of a conductive product through the metal detector are very difficult because they have such a big signal. And so the trickiness of inspecting cheese, especially large blocks like this, is traditionally been very difficult without having a lot of false rejects. And hence, sensitivities typical in the industry for large blocks of cheese have been in the 3, 4, 5, 6, and even 7 millimeter range. So what we want to demonstrate is with the CEIA metal detector, the multi-spectrum technology, and the ability for the machine to learn the product and then make selections of both high and low frequencies to try to eliminate the signals, the conductive signals created by the big mass amount of bulk cheese, but yet still detect the conductive and magnetic signals of both ferrous, non-ferrous, and stainless steel. So we're going to go ahead and run some tests, and then you can see the results yourself. Okay, so what we're going to do is now we're going to run a test with this 40-pound block of cheese. So I'm going to come over here to the program, and we're going to scroll down to Auto Learn. I'm going to turn it on. I'm going to keep the multi-level, the multi-frequency selection on, and I'm going to say we're going to pass it 3 times. So we're ready to go, and it says pass the product. So we're going to go ahead and pass the product through. And as it's going through now, it sees a lot of conductivity in this big mass block of cheese. Go ahead and pass it again. And it's trying to figure out which frequencies are best or right with the proper sensitivity so that we can ignore the product signal and then still just find metal. Go ahead. So it's now had the 3 passes to learn what it is, and you can see it's configuring. And it's figuring out the right frequencies, and then it's also selecting the sensitivity based on the signal so we can eliminate. So now you can see it's ready to go again. Let's go ahead and pass it. I want you to notice here the bar graph display. This is the amount of signal that I'm going to get when that passes through. Those 2 dots represent the threshold. So go ahead and let's pass it. Let's watch that. You can see I get, maybe 5 or 6 bars, but certainly not a detection. So I feel pretty confident that's pretty good. Now what I can do is I can look and see what actually the detection level is based on these settings. I can hit the status button, and it tells me that at these settings, I can detect 2.5 millimeters ferrous, 3.0 millimeters non-ferrous, and 3.5 millimeters stainless steel. So again, on a really big, bulky block, my detection level is 253035, yet when I come back out and we run that product through again, you watch that bar graph display. That's what I'm concerned about as my threshold there. And go ahead and run it. We can see we get a little bit of signal, but not anywhere near the threshold for detection. So now we've run some tests on these 40-pound blocks of cheese, and we've done an auto learn with both blocks. One of the unique features about the CEIA is we know that the cheddar and the mozzarella have different signals. There's some different levels of conductivity in the 2 different flavors. And then trying to accommodate those, traditionally we would say that you would set it up for cheddar and this one would be for mozz, and there'd be 2 different settings, and you're relying on an operator to make those changes as you change products and or size. There is some benefits here with the CEIA that you can do with this multi-spectrum technology, and that is when we do an auto learn, I can actually take 2 products and I can tell it I want to do 2 passes. And pass number 1, I can run the cheddar, and pass number 2, I can run the mozzarella, and it'll figure out in the different products, different settings, and in those settings, it will come up with a common setting that allows you to run both types of cheese under the same setting. And so the trick in doing this is again, for this big, massive conductive block of cheese that presents a big conductive signal, just like the metals do, is running this through, eliminating the signal from the cheese, whether it be the cheddar or the mozzarella or both, in the same setting, but still being able to find metal. So what we've done is we've gone ahead and set that up, and I want to show you now what the net result is when you run that. So now we've come up with some common settings for both the cheddar and the mozzarella 40-pound blocks. Again, this cheese is at nearly room temperature by now, but we wanted to show you a little bit. So you can see here we've just got a common setting cheese. This is the bar graph display. One bar is always present. Those two bars there, those two tabs, represent the threshold of the product signal, and once you cross that, it's a detection. At the current settings, I wanted to show you, you hit the status button, and you can see it's 245 sensitivity, mode 4, which is multi-spectrum, multiple frequencies simultaneously, 3.5 millimeters ferrous, 4.0 millimeters non-ferrous, and 4.0 millimeters stainless steel is the current detection level. So what I want to show you now is we're going to go ahead and run, and you can watch the bar graph display, and it's going to show you on the detection a number which represents the decibels or the strength of the signal from the detection. And then it's also going to freeze over here so you can have a visual of exactly how far or how well you got it. You'll also see this bar graph display bounce around a bit. So the first block that we're going to run is the cheddar block, and we're putting 3.5 millimeters stainless steel. You can see that when it passed through, 6.8 decibels, and it stops there and holds to show you that it's well beyond the threshold for detection. So we feel really confident that there's no problems there. Now, just to show you really an important step in this is to also show you that the cheese itself, the block itself, is not setting the detector off. So we're going to go ahead and run just now that same block through the detector, and it's really important to watch that bar graph display because what we're interested in is not getting close to the threshold. And here we go. So you can see we got just a couple of bars there, which means that I'm nowhere near the threshold of a potential false reject, but yet my sensitivity is still really, really good. That was 3.5 millimeter stainless. It shows us 4 millimeters in the dead center. So we really feel confident about that. Now what we're going to do is we're going to go ahead and run the mozzarella block. And I want you to watch the display. 2 or 3 bars, that's just the cheese only. Now we're going to run that same mozzarella block, and we're going to go ahead and put the 3.5 millimeter stainless steel on there again, and now you watch the display. You can see a very good size detection, 8.6 decibels, well above and beyond the threshold. And the important part is here is at this level, we're getting really good detection, 3540, and in fact, we're actually getting 3.5 millimeter stainless steel. As you can see here, that's the card. But we're getting virtually no signal or 2 or 3 bars of signal. So a lot of room between here and the threshold for false detections. So with this, we're very confident of these levels without getting false detections from block to block or variation to variation. And even in this case, it represents settings that accommodate both the cheddar and the mozzarella under one setting, so there's no need to make changes. So now what I want to talk about is something really unique to this CEIA. We talked about different inspection modes and being multi-frequency simultaneous. There is also some options to run this machine. Although the filtering is better than a standard single frequency, I can actually force this into a single frequency mode like most conventional metal detectors. Whether they have multiple frequencies, they're typically running one frequency at a time, or even metal detectors as late as 1995, 2000 were running, have been running single frequencies alone. I want to show you here we have forced this machine now into mode 1. Mode 1 is single frequency 300 kilohertz. You can see that by doing that now with this cheese and doing the auto learn at 300 kilohertz, like most machines that are currently running in the industry right now, the detection level is 4.5, 4.0, 5.0. But what I would like you to watch is now when I run that cheese at a much higher sensitivity, I want you to watch the product signal. You can see that product signal is bouncing up here now, and that was the mozzarella. And then if we run the cheddar, you can also see something very similar with the cheddar as well. Watch that product signal as it goes through, about halfway. So we know now that 300 kilohertz single frequency, you're getting signal about halfway to the threshold, which gives you less variability from block to block to block, and the potential for false rejections. And at that level, it's more consistent with what the industry is currently doing on 40-pound blocks. Interestingly enough, now what we've done is we've actually changed the sensitivity in this 300 kilohertz single frequency to 177 to match what the detection levels we were getting on the multi-frequency mode. So now at these levels, to achieve that same sensitivity that we were giving in the multi-spectrum mode, mode 4, I'd like to now watch and see what happens with the product signal here on the bar graph display as we run these blocks. You can watch. You can see we're right at the threshold. So to maintain those same levels of sensitivity, what we're running into now is at that sensitivity level, we're on the edge of false detection or false rejects to try to maintain that same level of sensitivity running ferrous, non-ferrous, and stainless steel as we were achieving in mode 4 with the multi-spectrum mode. Now what we've done is we've done another little reiteration of this product testing. Traditional metal detectors have a single frequency, or they'll operate on a single frequency. They might have multiple frequencies in the detector, but when they go to do a setup, it will select one frequency. And traditionally with big bulky products like cheese, especially these 40-pound blocks, the only way you can run those blocks of cheese on a single frequency, traditional metal detectors have lowered the frequency. And if you lower the frequency, it minimizes the signal from the product, but it also decreases your detection level. So in this CEIA multi-spectrum MS21, we actually have multiple settings that we can run at. So here, now we've switched it to detection mode 2, which is 150 kilohertz single frequency. And we did an auto learn with both blocks of cheese. You can see now that on the 150 kilohertz, the detection level is 4.0, 5.0, 6.0. This is very typical for 40-pound blocks with standard industry capabilities in metal detection with single frequency machines. And now you can watch what happens when we run the blocks of cheese in this mode. Again, you're getting about half of the signal. Same thing there. So the important part here really is understanding that if we need to get back to that level that we were at with the multi-spectrum, at 150 kilohertz, it's actually not possible. You can't run the sensitivity up higher. And again, this is what the industry's done, is they've selected some mid-range frequency for big, bulky products, and this is about the results you can get.